One way to increase the survival rates of cancer patients is through early detection. The earlier cancers can be detected, the higher the chances of cure. Scientists have identified several biomarkers which can be associated with several types of cancers. These biomarkers, which can be in the form of proteins, for example, are present in the blood at extremely low levels during the onset of cancer. To detect them, we could use nanotechnology in the form of gold nanoparticles. These nanoparticles have sizes smaller than the wavelength of light, and because of this, they absorb light within a specific region of wavelength. Because of this, gold nanoparticle solution is not golden, it is red. It is due to this phenomenon that we can detect biomolecules. One of the most effective ways is to coat these nanoparticles with molecules which can bind to the biomarker of interest. In the presence of the biomarker, the nanoparticles would come together and aggregate. It changes the way it absorbs light, and the color of the solution would gradually change from red to purple. This technique is highly sensitive, but there is a problem. The sample to be introduced needs to be clear and transparent for you to see the color change. How then can we detect the biomarker of interest directly from blood? One might suggest that we immobilize these nanoparticles on a surface, introduce blood, make these nanoparticles move around and aggregate, and then wash the blood off, and hopefully see a color change on the surface if the biomarker is present. Now wait a second. I said immobilize nanoparticles, and I said make nanoparticles move. It sounds like a contradiction. Moving immobilized nanoparticles. Can it even work? This represents the central challenge of my thesis. I overcame this by placing nanoparticles on polymer brushes which are grown from transparent glass. These polymer brushes swell in aqueous environment, so when I introduce blood, the nanoparticles are forced to float around the surface. And in the presence of the biomarker, they would come together and aggregate. I could then wash the blood off and observe color change on the glass. By using this technique, we could detect thrombin, which is a model protein, down to sub-picogram per milliliter levels, which is about 10 million times lower than the amount of sugar in the blood, and about 100 times lower than most cancer biomarker threshold limits, the amount above which can tell if someone may be prone to cancer. As this technique is simple, straightforward, portable, and possibly cost-effective, we hope that we could one day use this in clinics and hopefully save cancer-prone patients. Thank you.